Hello, kids. Welcome to Adding Fractions with Common Denominators. So this is going to be a lot of fun. We're going to be using the fraction pieces here. I've printed out an equal sign and a plus sign here for us. So this should be exciting, looking for common denominators. The first thing I want to talk about with respect to fractions is a fraction is a part of a whole. Fraction from the root fractus means like broken, like a split off part of something. So when we add fractions, we're adding parts of things and we make it wholes, we make it more than wholes. So fractions in the very name is something about something broken off or something that is broken off from a whole. We get the same root is used for the word fracture, for example. So let's talk about the Latin roots behind numerator and denominator. So we know that with fractions we have a numerator and a denominator. The numerator is the number on top, and the denominator is the number on the bottom. So most of this is review, but a fun little fact for all of us, and you guys know I love my Latin, is that the Latin roots, numer is the Latin word for number, and nomen is name. So the numerator is the one we count, and the nomen or the denominator is the one that is named. So this is a really interesting element of the Latin roots behind numerator and denominator. A couple of other things that we need to talk about are obviously other words and this fancy word called nomenclature, which is just a big word that means words that we use. So big words that we use. So numerator, denominator, whole number, proper fraction, mixed number, and improper fraction. There's also another one called an apparent fraction. We may talk about that later. I don't want to dwell too much on the nomenclature because you know that for the most part. Let's just go right into adding fractions. So let's start with 1/2 plus 1/2, and that equals, well, let's see what it equals. Equals 1 whole. Let's double check. Got some extra half pieces. 1/2 plus 1/2. Oh, it does in fact equal 1 whole. So the principle behind adding fractions is you take a part, this is 1/2, and you take another part, this is 1/2, and you add them together, and you get a whole. And a whole is represented by the round circle here. So 1/2 plus 1/2, there is a common denominator. So let me write this down to show you the common denominator. We write 1/2 in the abstract plus 1/2. We have a common denominator. And remember, the denominator is the one that is named on the bottom. The numer on the 1 is the one that is counted. So the numerator, 1 plus 1 equals 2. And the one that is named stays the same, 2 over 2. And that is the same as 1 whole. Because we will learn that 2 divided by 2 is in fact 1. Any number divided by itself is 1, which is why anytime you see that, that is 1 whole. And in fact, 2 over 2 is what's called an apparent fraction. It seems to be a fraction, but is in fact a whole number. All right, so that is 1/2 plus 1/2. Let's move on from the easy stuff, and let's go to a different one. Let's do 1/2 plus 1/4. All right, so 1/2 plus 1/4 is going to give us this. It looks like Pac-Man. It's going to give us Pac-Man, right? Well, we have a problem here. I mean, sure, it tells us how much of a whole it is. It's not a whole, but it's part of a whole. But exactly how much of the whole is it? So what we're going to have to do is we're going to have to get common denominator. So 1/2 plus 1/4 equals, there's my problem. And the issue is that 4 is different than 2. So what can I do to find a common denominator? Well, what I have to do is I have to find what is the smallest number that both 2 and 4 go into. And the smallest number that both 2 and 4 go into is in fact 4. So if we take and go back here, this half piece here, we realize that we can break this down into smaller parts because guess what? 2 goes into 4. if I write this down, so 1/2, I multiply the numerator by 2 and the denominator by 2. Okay, and that's going to give me 2/4. Oh, I have a common denominator. But how does that look in the concrete here? Well, the 1/2 I can break down into 2/4. So the 1/2 has become 2/4 pieces added together. Let's double check to make sure it's the same thing. Yep, it is. So 1/4 and 1/4 together make a half. And we're going to add those with this 1/4. All right, so let me show you just to make sure you know. So there's the 1/4 and 1/4 together. And we're going to add it to this 4th. And then we get Pac-Man. No, just kidding. We get, let's count the 4ths together. 1, 2, 3. I don't have to show them like that. I can do it like this if I want. 1, 2, 3/4 there. Doing it in the abstract, doing the same thing we always do. The denominator, the one that is named on the bottom, stays the same. And the numerator, that one is the numbers that we add. And 2 plus 1 is 3. So we know that 1/2 plus 1/4 is the same as 2/4 plus 1/4, because 4 is the smallest number that both go into to form a common denominator, and they add up to 3/4. All right, that was a fun one. Let's do one that's a little more challenging now. Put these 4ths away. I'm keeping the whole out just to remind you that this is a whole. Okay. Let's do 1/3 plus 1/6. So I've got 1/3 and 1/6. All right, so let me write that down in the abstract for you. Okay, well, if we add them together, oh, dear Lord, sorry. It looks like this. Okay, that looks interesting. I wonder what that looks like. Well, let's keep that in mind. That's pretty visual right there, what that answer is. But I want to show you how we do this with getting our common denominator. So we realize that 1/3 and 1/6 do not have a common denominator. What's the smallest number that both 3 and 6 go into? That's right, you said it, 6. So I'm going to multiply my 1/3 by 2/2, and that's going to give me 2, I added, whoops, 2/6 there, plus the 1/6 there. Okay, now all I did was turn the 1/3 into 2/6 by multiplying it each one by 2, the numerator by 2 and the denominator by 2. That's the trick to getting your common denominator. You're multiplying it by 1. You're keeping it the same. You're just making it not the lowest reduced form of the fraction. So we have 2/6 plus 1/6, and that gives us 3/6. Okay. 1/3 there has become, oh, I forgot to do it in the concrete. My bad. So that 1/3 has become 2/6. It works. It absolutely works. All right, that has become 2/6. The 1/3 has become 2/6. I add them together, and I get 3/6. However, if I put them together like this, they give us a hint as to what the reduced form is. What is the reduced form? Well, we're in a situation here where 3/6 is not in the reduced or the lowest form. 3 is half of 6, right? Well, what do we do to get there? Well, we divide each of them by 3 to get 1/2. Let's double check, see if our math is correct here. This is how we're finding it. Let's see if the 1/2 piece goes over this 3/6 here, if that is indeed correct. Lo and behold, 3/6 is equal to 1/2. That is amazing. That is awesome. So we are rocking and rolling here with finding common denominators. So let's do another one. Let's level up a little bit. Let's do 2/5 plus 3/10. 1, 2, 3. I might as well make it look good here. So let me show you what the 5th looks like there. There's the 5th. I have 2 of them. And there's a 10th. I have 3 of them. So when I add them up in the concrete, it's going to look like this. Okay. Looks like kind of Pac-Man with his mouth open real wide. But we don't know exactly what that is yet because I do not have a common denominator. So I'm going to go ahead and put my 3/10 back here and my 2/5, and let's write this down. 2/5 plus 3/10 equals. There's our problem. All right. Well, we need a common denominator. What is the smallest number that both 5 and 10 go into? If you said 10, you would be correct. So it looks like 2/5. What do I multiply 5 by to get 10? 2. I have to do the same thing to the numerator. 2/5 is equivalent to 4/10. I bring down the 3/10. And there I have it in the abstract. Let me show you the concrete. Let's see. It looks like it takes 2/10 to make a 5th. So 1/5 is equal to 2/10. I gotta get 2 more of these. Yep, I'll prove it to you. Hold it up here for you. All right, okay. So we're changing these out. Now I have in the concrete 1, 2, 3, 4/10 plus 3/10. Let's move them all over. And kids, this principle works no matter how hard or difficult the problem. I'll do one more to show you what happens when we get an improper fraction, and we can turn it into a mixed number. That's not the main focus of the lesson. 2, 3, 4, 5, 6, 7. Let's check to see if I have 7/10. Well, following the logic of adding fractions, 4 plus 3 for our numerator is in fact 7. Denominator, the one that is named, stays the same. Our answer is, in the abstract, 7/10. Our answer in the concrete is 1, 2, 3, 4, 5, 6, 7/10. Very, very awesome. Love that. So you're going to run into some situations, though, when you're going to end up with something more than a whole when you add these together. So let's do 1/2 plus 3/4. Okay, so I've got a half there, and I've got 3/4. Okay, I'll show you what that looks like when I write it down. And this is where you cannot get scared. You just have to know what's going on here. And I'm going to talk to you about what this is going to form. This is going to form what's called an improper fraction. It's not proper. A proper fraction is when the numerator is smaller than the denominator. An improper fraction is when the numerator is larger than the denominator. And here we have 2 proper fractions that we're adding. Unfortunately, we do not have a common denominator yet. So what's the smallest number that both 2 and 4 go into? Did you say 4? If you did, you would be correct. Let's see, 1/2. If we have to multiply the denominator by 2 to get 4, we have to do the same thing for the numerator. So 1/2 becomes 2/4 plus 3/4. Looks looks like that. Okay. Well, I got to change these out. Do the same thing here. So this is, oops, that's a fifth. So this is 2/4. Let's double check. Let's not just trust me. You got to know for sure. Is 1/4 and 1/4, 2/4 the equivalent of 1/2? Yes, it is. That's the great thing about these materials, kids. They don't lie. Math is what it is. So 1/4 and 1/4 together are going to give us 1/2. Let's add the 2/4 with the 3/4. Let's see what we get. Uh-oh. We already have a hole here. You have an extra, because I told you before this is a hole, but now I have a hole with some extra. What does that look like? Well, how many fourths do we have? 1, 2, 3, 4, 5. 2 plus 3, 5 over 4. That, kids, is an improper fraction. We don't like that. So what we're going to do is change that into a mixed number, so it's actually going to look like this. So we say to ourselves, 5 over 4, 5/4. Well, we know that 4/4, 1, 2, 3, 4, is equivalent to a whole. So if 4/4 are equivalent to a whole, that's 1 whole. And how many fourths do I have left over? I have 1/4 left over. And this is where the concrete materials really help kids, because you literally see what the leftover is after the whole. So I have 1 and 1/4 left over. Look at that. 1, 2, 3, 4, 5/4, improper. 1 and 1/4, mixed number. So that's going to happen sometimes when you add fraction, kids, and that's okay. It's a lot of fun, actually, to do it. So let's do one more problem, and then I'll talk to you about some of the materials that I'm going to post on the Google Classroom so that you can cut out pieces and create your own fraction problems and have fun. And kids, if some of these smaller numbers are too easy for you, that's great. Guess what? You can create fraction pieces of up to like a 20th or a 25th or something. They're going to be really tiny, but have fun. Like, I would love to have somebody be like 17/25 plus, 6/20 equals what? So the sky's the limit with your practice. And parents, I encourage you to give your kids practice problems that really match where they are. I'm giving the principles right now. Most of us know some of this already, but I'm trying to reinforce it with the concrete material. So let's do one more. Let's do 2/3 plus, let's get crazy here. 1, 2, 3, 4, 5/6. Let's do that. No, let's get even crazier. You know what? I'm 1 and 2/3 plus another 1 and 5/6. You know what? Sometimes you just gotta have fun when you're in the middle of a presentation. So that's what I'm gonna do. All right. So let's write it down. 1 2/3 plus 1 and 5/6. Now, kids, do not panic. Guess what? We add the whole numbers first. We know that we're going to have a 2 over here. We may have something to add to it, but we're going to have a 2 wholes. Okay, so I'm just going to write 2 wholes here. And I'm going to move them over. So we know that our answer is going to have at least 2 holes in it. Okay? Now, all we have left is the 2/3 and the 5/6. Again, we ask ourselves, what is the smallest number that both 3 and 6 go into? And if you said 6, you would be right. We do the same thing that we've always been doing. What do you multiply 3 by to get 6? Multiply that by 2. Have to do the same thing to the numerator. You always got to treat the denominator and the numerator fairly. Always. When you're like making it bigger or smaller, always treat them fairly. Kids usually understand fairness a lot. So 3 times 2 is 6. 2 times 2 is 4. It looks like 2/3 is the equivalent to 4/6. So I have 4/6 plus 5/6. Let me change these guys out. I don't need to prove it to you anymore because we've already done these ones before. 1/3 is the equivalent to 2/6. So 1, 2, 3, 4/6. So if the 2/3, check, that is equivalent to 1/3. That is equivalent to 1/3. Yes. So 4/6 plus 5/6 is going to give us, let's pull them over, 1, 2, 3, 4. Help me out here, Rug. 5, 6, 7, 8, 9. So is that the same thing over here? That's right, 9/6. 9/6. Wow. We have 9/6. Well, how do we get a whole? We have to put the 6 together, and we'll see how many 6ths form a whole. 1, 2, 3, 4, 5, 6. Okay, so these 6/6, an apparent fraction, actually forms, where's my other one? A whole. That is correct. So we actually have 3 and 3/6. Because I added another whole, and I had 3/6 left over. So there it is, 3 and 3/6 left over. Now we have one more thing we could do. I know I'm out of space, but I'm going to figure it out anyway. 3/6, can we reduce that? What is 3/6 equivalent to? Well, let's put them together and see. Oh dear Lord, looks like 3/6 is equivalent to 1/2, and that is correct. So let's reduce 3 and 1/2. I'm deeply sorry about the potato quality here, but there it is at the bottom, 3 and 1/2. And that's what happens when you add 1 and 2/3 plus 1 and 5/6. You end up with 1 and 4/6 plus 1 and 5/6 gives you 9/6, which equals 1.5, and you add it to the two whole numbers, and there you have it. So 1, 2, 3, and 1/2. All right, so I have some materials that I have from Montessori for Everyone. A whole bunch of printouts that you can make, and actually I'm thinking about doing another PDF too where I scan fraction pieces so you can cut them out. But I went ahead and cut out some fraction pieces here out of paper myself. And what you can do is you can make your own fraction problems at home and impress your parents with how much you know fractions. And you don't have to do the simple ones like I've got here. So for example, 1/2 plus 1/2 equals a whole. You don't have to, you can, and this is very simple. I only cut these out for an example. But you could do 1/2 plus 1/4 equals, we figured this out before. That was 3/4 because that is equivalent to 1, 2, 3/4. So you can do those. And what I recommend is that you create 5 problems. Just create 5 addition problems at home with the fraction pieces and write them out. So you would do something very similar to what we were doing here, where you created your problem, 1/2 plus 1/2 equals 1 whole, right? And so you would do that, and you would lay those things out, or draw them. You can even draw them if you want. And then you could write it out in the abstract as well. That's one of the easiest ones there is. So usually for kids, for 4th graders, denominators, if you're a beginner, I recommend denominators 10 and below for your I guess you could call them your add-ins here, because then you're going to come up with common denominators that aren't too big. If you're someone who's more advanced and you want to use common denominators that are a little bit bigger than that, or you want to use denominators for each one that are a little bit bigger than that, challenge yourselves. Have fun. Fractions are great for those of you that are beginners at this, I say keep it simple and stick with denominators of 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if you want to push yourself, do denominators that are larger than that. It would get pretty complicated if you did something like this, but some of you may want to do this, and I'm awesome with that. Oh, Mr. Adam, you said it had to be under 20. Well, 7/19 plus 3/18 equal. Whoa! That one's pretty tough because finding a common denominator for that one's going to be very difficult to do, especially since 19 is a prime number. So, you know, that one's going to be a little bit more difficult. But I encourage you to do so if you want to. And that's great. I hope you enjoyed this lesson on adding and finding the common denominator. I highly recommend you print out whatever I send you, put on the link, the Google Classroom link, because the visuals, kids, the visuals like this, they help out so much to see how fractions actually work. So I hope you enjoyed this presentation. Have a great day. Enjoy. Next up, I think I'm going to talk about subtracting with same denominators and then figuring out subtraction with common denominators. Bye.